3. So now we're starting to get excited, okay, because we've got 2 to the power of something times 3 to the power of something on the left. And now we've got 2 to the power of something times 3 to the power of something on the right. Why am I getting excited? I'm getting excited because if I have like bases, I can equate my exponents and solve. Okay, but I still need to deal with this root. So what I can do, if I want to all in one step, what you would do is you would write that 96 as 96x divided by 2. Does that make sense based on the discussion that we were having earlier? So to get rid of the root, I would need to divide the exponent by 2. Yes, okay. Now I'm going to write 96 as 2 to the power of 5 times 3. And now I've got to raise that to the power of x over 2. So someone was asking about fractions. Fractions are coming in here as well. So we've got all these different concepts coming at us at the same time. But if we know what each of these concepts are, we can work with each part of the question as we need to, and it's not so intimidating. All right, now on the right-hand side, on the left, we're going to leave our 2 to the minus 5 times 3 to the y plus 1 until we're ready to work with that. And now on the right-hand side, when we raise a power to a power, we multiply our exponents. So you've got 5 times x over 2. So that's going to give you 2 to the power of 5x over 2. So your exponent is a fraction. And now we've got 3 to the power of an invisible 1. Okay, and that is also to the power of x over 2. Is everybody satisfied with how we've got to this point here? Are there any questions? Are we feeling good? All right. So you can see it's just application of concepts that we actually know, but which for some reason we're scared and we're intimidated by the question and we think we don't know how to do it. But actually we do. I mean, there's nothing here that I've told you that you actually don't already know. You know all of this. What's lacking is the confidence to actually try the question. All right, and to apply those rules. Okay, so when we solve for exponential equations, in this case, we don't want to use logs because we've got like bases. So in other words, what we are doing here is we are looking at this base with this exponent and this base with this exponent. Okay, and we have to solve for x first. We can't solve for y first because as far as the y is concerned, it's sitting on base 3 and an x is also sitting on base 3. And of course, we can't solve for x and y in the same equation. So we have to solve for x first. So my deduction here is that 2 to the minus 5 has to be equal to 2 to the 5x over 2. When I've equated my bases, I can equate my exponents. And now it is a hopefully straightforward linear solution. So I'm going to cross multiply the 2 with the minus 5. That's going to give us negative 10. So that would be equal to 5x divided by 5 on both sides. And x is equal to negative 2. Okay, then I'm going to do the same thing. Good. I'm going to do the same thing with my base 3's. Okay, so over here, I've got 3 to the power of y plus 1. It is equal to 3 to the power of x over 2. Now that I've equated my bases, I can equate my exponents. And in place of my x, I'm going to write negative 2 over 2. So I've substituted in my x value already. Okay, you could, if you wanted, write x there, and then in the next line, you do that, but I've decided to do it here. Sorry, I'm just scooching over a little bit to the right-hand side there. And now y plus 1 is equal to negative 1. So y is also going to be equal to negative 2 in this case. Yes. Good. Well done, everybody. Okay, so quite a lot of working out for something that's 4 marks, but there we go. Okay, so where are they going to give us our marks? Well, they have to give us our marks on our answers because they asked us to solve for X and Y, right? So we're going to have a mark on our X and a mark on our Y. The other marks in this particular question is going to be on this line over here, on accurately simplifying it. And then there would also be a mark on this line over here, getting your 32 into the numerator and writing it as 2 to the power of -5, and then working correctly with a 96. Okay, so there is just a little bit of revision for you guys on exponents and surds. How do you feel about that now? Yeah, thank you, Lebogang. All right, but if you know the rules, it's fine. You see, and I mean also, I've had years and years and years to practice these things, so they don't intimidate me as much as they did when I was in matric one day as well. Okay, so I understand why it's good. I'm glad. I'm glad, Marilyn. Okay. All right. So going back to where we were. So my hints and suggestions for you. I can, Joshua. That's fine. That's something that I can send to you. That's not a problem. I can ask them to send it out. All right. So just coming back to this before we continue. All right. So things we need to be careful of, common exam errors in paper 1. Be careful of rounding in question 1. Do you remember I told you the last time when we worked through that Watobe paper, they penalize on rounding in question 1.2. Okay, so make sure you round accurately to 2 decimal places when you use the quadratic formula. Okay, so this is about question number 1.2. And then the other little note that I wanted to make here is make sure that you show that you have subbed into. So show your sub into the quadratic formula. Okay, always, always, always. Okay, then check both solutions when squaring both sides. Do you know what I mean by that? You know which questions I'm talking about when I say square both sides? So Tristan says yes. The rest of you, yes. You know what I mean? We did one last week or the week before on boot camp. Yeah, so surd equations, exactly, Cheslin. Surd equations. So remember, yeah, the third one, yes. So remember to check both solutions. Okay. Then another place where students often lose marks is with quadratic and cubic factors. So if you are factorizing a quadratic expression, or even if they ask you to find the x-intercepts of a cubic function, make sure on the line where you have your factors, if you haven't used the quadratic formula, if you are factorizing, do not leave off the equal 0, even if you wrote it in the line above where you've written standard form. Okay, that's another place where we end up losing marks. And then the other thing that I wanted to highlight about question number 1 is make sure that when you solve a quadratic inequality, that you are not treating it like you are solving a quadratic equation. Quadratic inequalities are not the same as quadratic equations. Do you want me to do another example of a quadratic inequality, or are we good? Just one more example. Okay, all right, that's fine. That's not a problem. Yes, an example. Okay, cool. So I've got one here. Let me just grab it quickly. There we go. 1 second, guys. So again, this comes out of your 2022 paper. I thought that this would be the most relevant one to be able to give you. Okay, so let's put that over there. Do we have space? No. Hold on 1 second. Let's just scooch over to the side here. And let's put this up there. Okay, so this came out of, as I was saying, last year's paper. Yes, it's absolutely. So with each little question, Lebogang, there's things that we have to remember. It's so much, isn't it? There are just so many little minor details and things that we're expected to know because our syllabus is so very deep and so broad. Okay, so the first thing that we would want to do in question 1.1.3 is get it into standard form. So we need to transpose that x. So we're going to say x squared, and then to save ourselves a little bit of time, we can just go ahead and pop it in the middle and then put our minus 90 at the end like that. And then that is going to be greater than 0. So remember, we are dealing with a quadratic function. So we would look at this as y is x squared minus x minus 90. It's a parabola, isn't it? X squared minus x minus 90 is a parabola. And what we've got is our function on the left, and we've got our greater than sign is greater than 0. So here they are asking us to solve for x when y is greater than 0. That's what they're asking us to do. Okay, so our y values change at the x-intercepts. So our x-intercepts are our critical values in this particular case. It wouldn't. So the only time that a sign would swap around, Lebogang, is if you multiplied or divided by a negative. That's the only time an inequality sign could change from being greater than to smaller than. And that just works on the following concept. So let me just make a quick example, and then I'll come back to this inequality, because inequalities are conceptually difficult things to understand, right? Let's say I wrote a statement like 10 is greater than 6. Everybody's happy that that's true, right? 10 is greater than 6. But now if I come along and I divide my 10 by negative 2, and I divide my 6 by negative 2, I have got a problem because it's no longer true. If I keep my inequality sign as a greater than sign, I'm saying that negative 5 is greater than negative 3. And that's not true. So that's why the minute you divide or multiply, for that matter, by a negative, your sign has to swap around. Now, why is my eraser not working? Hold on a second. What's this thing doing? Why is my eraser not working? How? Okay, I don't know why it's doing that, but anyway, never mind. We'll just scratch that out and we'll do this. Okay, so that's the only time that an inequality sign swaps around. So you're not going to have to worry with questions like this. So like question 1.1.3, change your inequality sign. Where you're going to have to worry about things like that would be sort of later on in the paper, where they maybe asked you to work, like if you had to do a nature of roots interpretation, and you had to do something algebraically solving for the values of k for which it's a tangent or equal roots or something like that, then sometimes you have to divide by a negative on both sides, and then your inequality swaps on. Here you don't have to worry about that. So what's important here is for us to factorize our expression. All right, so we need our factors because those are going to be our critical values. So in this particular case, our critical values are what? Which two numbers, if we multiply them, no problem, are going to give us a difference of -1, and they multiply up to 90. It would be 10 and, or -10 and, yeah, so 10 and 9. All right, so in this case, because our middle value is negative and our last value is negative, the larger of the two factors is the one that needs to be, pardon me, the minus, and the other one needs to be the plus. Okay, so now we need to write down our critical values. This is not our solution. The critical values are where y changes sign. So at 10, y will change sign, and when x is equal to -9, y will change sign. Okay, the best thing for you to do, I always draw a parabola. I don't draw a number line, but it's up to you, is draw your parabola. Now, you know that your parabola is happy-faced because in front of the x squared, there's a +1. The smaller number always goes on the left. The bigger number always goes on the right. So think about a normal horizontal number line, your x-axis. It gets bigger from left to right. So the smaller number on the left, the bigger number on the right, always. Absolutely. Now, hang on a second, Joshua, because you cannot write your answer like that. Okay, so when you are writing an answer that goes between, this doesn't go between. When you're writing an answer that goes between, the smaller number needs to be on the left and the bigger number needs to be on the right. But it's got to be bigger than -9, but smaller than 10. Okay, so your inequality signs for a between always has to point to the left-hand side. Why is this now not working? That is ridiculous. Oh, I think that's what stroke eraser. Sorry, guys.
Try unsharing the screen and share again. Maybe that will work.
Maybe that'll work. I don't know why. Just hold on, everybody. I don't know why it's not playing game, why it's doing silly things with me now. Let's try that again. Or maybe I must try. No, still not. Okay, what I'm going to do is I'm going to unplug that and plug it back in again. Let's see if it works now. Still not. Okay. All right. So it's being a real pain in the backside. Okay. So in terms of our answer for this particular one, that is not the correct answer. And shading here is not the correct place to shade because they are asking us, where is y greater than 0? Y is greater than 0 over here and over here. So where the purple is, that's the correct place to be shaded. Okay, so your answer to this particular question is actually going to be where x is smaller than -9 or where x is greater than 10. That's it. Okay. All right, so Lebogang, we also can't have those signs pointing in different directions. So if you write X, you can't put this one in this direction and that one in that direction, because then it's not going to make any sense. If you read that, okay, X is greater than -9, but X is greater than 10. Okay, it doesn't make any sense. All right. So when you write a compound inequality, like the two that I've just scratched out, your inequality signs always go in that direction with the x in the middle. The smaller number goes over here on the left, and the bigger number goes over here on the right-hand side. Okay, or else it's split apart. Okay, it's discontinuous because there's a gap where our condition is not met between -9 and 10. Okay, so the previous answer, there was a continuum from -9 to 10. Okay, because it was between -9 and 10. Whereas here, it's everything smaller than -9 or everything that is bigger than 10. Okay, so that's how you would write your answer in this particular case. Okay, so this is the answer over here. That's the answer. That's what you're going to get the final mark on. Okay. And there's only one mark on that, and both have to be 100% accurate for you to be able to do that. So this particular question was out of 4. So there's a mark on this, mark on your factors, mark on your critical values, mark on your diagram. Or maybe what they would have done, oh yes, now of course I can't rub anything out, is maybe they would have given you a mark over there for getting it in standard form rather than on the diagram. Okay. Yes, you are supposed to sketch, because the thing is that the sketch is what informs your answer. Okay, so the sketch helps you to create that particular answer. Based off of what region you're sketching, that's the answer you're going to write down. Okay, so yes, you're supposed to do that. Okay. Is everybody happy with the quadratic inequality? So it's not a case of like a lot of students will then write down the bracket and they'll go x minus 10 is greater than 0, or x plus 9 is greater than 0. You see that a lot. Okay, and there you're treating it like a quadratic equation, and it's not, it's a quadratic inequality. So that is completely wrong. Okay, wrong concept altogether. Okay. All right. Sorry, I'm having to scratch things out. I don't know why my eraser is not working in this case. So just a few other bits and pieces. Sorry, we were talking about this thing over here, quadratic inequalities versus quadratic inequations, or quadratic equations. The other thing that you need to be careful of is your factorizing skills. So make sure that you are looking, and I mean, we've used factorizing so much. I mean, in question 1.3 over here, we factorized by taking out a highest common factor. Here, this was all factorizing, wasn't it? Where we were writing down this product from 1 through to 30. Then in this question over here, we factorized, again, we factorized 96. Here we factorized a trinomial. So you've got to be able to factorize in order to be able to do well in paper 1 and in paper 2. These are very important skills. Exactly. Even in trig, factorizing is everywhere, 100%. You know, especially when you're solving your or proving your identity, when you are doing your general solution, you're going to be factorizing as well. Okay, so then I had said learn your exponent and log laws. So your exponent laws are the ones that you know from grade 8. So when you multiply like bases, you add exponents. When you divide like bases, you subtract your exponents. When you raise a power to a power, you multiply your exponents. Anything to the power of 0 is 1. We used our exponent laws here as well. So we took a base from the denominator to the numerator. We changed the sign of the exponent. Okay, now the log things that you need to know, there are a lot of log laws, but they're outside of our syllabus. So Tristan, when it comes to logs, there are only 2 things that you need to know. Okay, the first one is this. Okay, you have got a number equals a base to an exponent. So number equals base to an exponent. When it comes to logs, so let's say you have y equals log base 2 to the x. When it's written in this way, all right, your exponent is equal to log base number. Okay, that's what they expect you to know in order to be able to go between the two. All right, because remember, as we go from number 1 to number 2, we've switched x and y. So in other words, we've now got x equals 2 to the power of y. Okay, so when we write over here our exponent, that's why we're making y the subject to the formula. Log base 2, and then we're putting our number over there. Okay, does that make a little bit more sense, Tristan? Have you seen that before? Yes. All right. So make sure you know what I'm saying here in pink. The bit that I'm encouraging you to study, the 2s are just an example, is this bit over here that I've put a pink circle around. Make sure that you've learned that. Okay, and then say it to yourself in your head when you are writing it down. Okay. Now, another place where people commonly lose marks in paper one is selecting the incorrect formula to use. All right, so this is particularly apparent in sequences and series, but also in financial maths. Okay, so in sequences and series, make sure that if you're working with an arithmetic sequence, if it's not a series, that you use the TN formula. If you are doing an arithmetic sum, then you can use the SN formula for arithmetic sequences. If you're working with a geometric sum, you've got to use TN equals AR to the -1. If you're working with a geometric sum, you've got to use the correct formula. And if the question implies that something is infinite or it continues forever and ever, then you would use your sum to infinity. Okay, so just make sure that you use the correct formula based off of what is given to you. Okay, and they will always tell you whether the pattern is arithmetic or geometric, except in situations where they give you a sequence of numbers and then they don't tell you whether it's arithmetic or geometric. So there are sometimes situations like that. How will you know the difference between the two? So if they gave you a sequence of numbers and they didn't tell you whether the pattern was arithmetic or geometric, what would you do to test? Exactly. So you would check for differences. If there was a constant difference, then you know that it's arithmetic. Good, Msomi, that's lovely. Or if there was a common ratio, if term 3 divided by term 2 was the same as term 2 divided by term 1, then you would know that it was geometric. Okay, so just be careful of that. Make sure that you use the right formula. And then in financial maths as well. Okay, so we spoke about that a little bit last week. What I'm going to do is I'll just pop it over here. So in financial maths, okay, more so than anywhere else. So I'm just going to make a heading, financial maths. Okay, if a question uses the word pension or retirement annuity or savings or investment or sinking fund, for all of those, you are going to use the future value formula. If the question uses the word loan or inheritance or winning the lottery, you are going to use the present value formula. Okay, and they're very strict about that. You've got to use the correct formula, otherwise you're not going to get the right answer. So there is often a mark in financial maths, well, not often, there's always a mark in financial maths for substitution into the correct formula. If you do not sub into the correct formula, you're not going to get any marks. The other place where you've got to be careful about substituting into the formula correctly, another common error that's made more in paper 2 really than in paper 1 is with gradient. Make sure you are putting the change in y at the top and the change in x at the bottom. If you switch those two, and that often happens, and you put the change in x at the top, you will get no marks for substitution. Okay, so those were just some little hints when it comes to financial maths. The other thing that you must do for financial maths, yeah, balance of a loan, absolutely. So that's point number 9. Okay, so learn outstanding balance is A minus future value. Okay, do you remember that from the last time we spoke about it? Maybe I should scooch over and just make you a little note on that too, because you guys can always take screenshots here. Okay, so remember when it comes to outstanding balance or balance on a loan, there are 2 ways in which you can solve the problem. You will always be able to calculate an outstanding balance using A minus future value. In this situation over here, your N value is the number of payments that have been made. Okay, so I'm just going to write that for you again. So for this one, it's the number of payments already made. Okay, so N equals. The second way that we can do it is to use present value. Okay, here, let's use a different color. N is going to be the number of payments that need to be made. Okay, so you may not always know the number of payments that need to be made if they don't tell you the length of the loan. So you will always be able to do that using option number 1. Okay, another thing that I had put on that list, which I'll just put down here since we're talking about financial maths, is nominal and effective interest rates. Does that ring a bell? It comes up very, very, very occasionally in matric. Right, so they will ask you to usually give you a nominal rate and ask you to make it an effective rate. Okay, so the formula here, and this is not on your formula sheet, is that the effective interest rate is going to be 1 plus the nominal rate divided by m to the power of m minus 1. Does that ring a bell? Yes. Okay. So IE is your effective rate. IN is your nominal rate. And M is your compounding period. Okay, so make sure that you've learned this formula too, not on your formula sheet. And as I say, it does come up very occasionally, not very often, but very occasionally it does come up as well. Okay, so that is another place where, if they ask you to calculate an effective rate from a nominal one, it's actually such a simple procedure, and I mean, that could be 2 or 3 marks. We want all the marks that we can get. We don't want to just throw stuff away just because we didn't learn a formula. Okay. All right, so going back to our rules over here, we've spoken about all of these. We've done that one, 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 done that one, done that one. Nominal and effective rates, we've spoken about outstanding balance. Now, the other thing that I wanted to talk about, because the next big section in paper 1 is going to be on functions, as you well know. So there, if you want to take pictures of those, you can. These are just some of the things that you need to. That was just an example I thought I might do if I need to. So here is number patterns, about 25 marks. Finance is about 15. You can take a screenshot of that as well, just to make sure that you know all those things. The other one I just want to mention, actually, before I go on and talk about what I wanted to speak about with regards to the parabola, was this reducing balance depreciation. They always ask a question on reducing balance depreciation. So remember your reducing balance formula. Reducing balance is the one where it goes A equals P1 minus I to the power of N. Okay, so that is your reducing balance formula. You know which one I'm talking about. They often ask questions on a reducing balance. I will, Kutlwano. I'll ask them to send them to you. Okay, I'll remind them. Okay. So then we get to functions, and the different kinds of functions that we have to be able to work with would be our inverse functions, our linear functions, our quadratic function. Now, what is missing off here, unfortunately, is this. So I'm just adding it in, and it's 35 marks, so it's a lot of marks. So the other thing that you need to be aware of, yeah, that's a good question. Have you received the memo for paper 1? No, not yet. Oh, maybe they're waiting until the end of boot camp. I don't know. I'll follow up on that, because I mean, you must be finished with paper 1 by now, I would imagine. Okay, so you haven't received it yet. Maybe they're waiting to send it out to the end. Okay. All right. Well, then I'll send the lady in charge of sending that out. I'll send her a message, and I'll just make sure that she sends you these checklists as well. Okay, and then you can just go through that and say yes, 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 or no, 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 I need to focus on this as well. It helps. Yeah. So Joshua, whether you write X1 and X2 or root 1 and root 2, it really, really doesn't matter. So I'm just bringing this to your attention, because when it comes to the parabola, they can either give it to you in standard form. So the yellow one over here, that's your standard form. Or they can give it to us in turning point form. And this one at the end doesn't actually have a name, the blue one. I myself refer to it as root form, but that isn't its official name, right? So often what students struggle with, another common exam error, is knowing which one of these to use in what particular situation. All right, so I just wanted to talk a little bit about that. Okay. You would use turning point form if you were given the turning point and another pair of coordinates, another pair of coordinates. This, I'm sorry, what I'm referring to here specifically is if you are trying to find the equation. So if you are trying to find the equation of a parabola, you would use this form over here if you were given both x-intercepts and one other point. Okay. Do you want me to do an example of what it is that I'm talking about just very quickly? Yes. Okay. All right. Just give me 1 second. I'm just going to grab a question. All right. Just give me 1 seckie. Which one was I thinking of? Let's just have a look here. Sorry, guys, I won't be long. That one's not going to help us. Okay, let's see here. Sorry, this is not one of the ones I pulled out an example of. Okay, you know what I'm going to do, because I'm wasting time here. So I'm just going to make up an example. All right, rather than grab an actual question. There's just one specific thing that I want to remind you of. Okay, so let's draw ourselves a set of axes. It's that one. And let's label that as X, and that is Y. Okay, there we go. And let's put our parabola. Okay, excuse my horrible parabola. And I'm making up values here, but whatever we get, it will work. Let's pretend that that is -4, and let's pretend that that is 1. And let's say they give you one other point that lies on the line. It could be any point, but let's pretend that it is the y-intercept, and let's say here that it is 0 and -6. If they asked you to find the equation of a parabola under these circumstances, this is when you would want to use what I'm talking about here, which is this root form. Now, this is very important because you also need this if you are trying to find the equation of a cubic function. There's just going to be an extra bracket. Okay. So that's why I'm highlighting it to you again, because it's something that's important that we use later on. So what you would do is you would write down your equation in this form: y equals a, x minus, and whether you use x1 or root1 or root2 or x2, it really doesn't matter. Okay, so x1 and x2 are your x-intercepts. Sub them in first. So you would go y equals a, x minus -4 would become +4, and x minus 1, we know that it's got to have the opposite signs. So after you have subbed in your x-intercepts, sub in your other point. So now your x is 0 when your y is -6. So I'm going to put in -6 over here. I'm going to keep the a, and now I've got 0 plus 4. Sorry, that should be a 0. Is this going to work now? No, of course not. Okay, let's change that into a 0 minus 1, like so. So these brackets are being multiplied together, and then they are being multiplied by the a value. So you've got 4 times -1 times a is -4a, and it is equal to -6. And now, unfortunately for us, a ends up being a nasty fraction, but it can be a fraction. So a is going to be -6 divided by -4. So we would end up with 3/2. All right, so in these circumstances, you are always solving for your a. Do you remember how to do this now? You just needed a little bit of reminding. Okay, right. And then once you have got that a value, if they ask you to find the equation of the parabola, you now need to sub it back in. So we've got 3/2 x plus 4 times x minus 1. And you typically wouldn't leave it like that. You do this for the cubic as well. Yes, Cheslin. You can do this for the cubic as well. Okay, so that is important. And then you'd obviously have to multiply your brackets out. So you'd have a couple of extra lines here. You'd end up with plus 3x minus 4. And then your final step would be to remove your brackets. So that would be plus 9x over 2. And then it would be minus 6. Okay. So that's what I am referring to. Is everybody happy with that? Gosh, I can't believe how quickly the time goes. Can you guys believe it's already 20 past 4? It's crazy. Okay. Where were we? So we'd spoken about that, and then your transformation. So the difference between changing X and changing Y. So what I'm referring to there is if they give you things like this, all right, so we can just write these down. If they tell you that there's a transformation that's taken place and they say h of x equals negative f of x, what did they do to h of x? What did they do to f of x to get h of x? No, that's not a shift up or down, I'm afraid. This is a reflection. Okay, so here what we have done is that we have multiplied y by -1. Okay, so we've changed the sign of y. So if we're changing the sign of y, I saw someone said it's been reflected in the x-axis. Absolutely. Okay. So you have changed the sign of y. Therefore, you have reflected it about the x-axis. If I say in a different example that h of x is equal to f of negative x, then have I changed the sign of y? No, I've changed the sign of x. Okay, so I have changed the sign of x. So in other words, I have reflected it about the y-axis. Okay, if I say something like this, let's just get rid of this one. That's just another example on exponents. If I do something like this, what am I doing here? I am adding onto x. Can I show you how the denominator is affected? Do you mean it for the green one, Gugu? Or do you want me to show you with both the orange and the green? Okay. So Gugu, if they gave you something like this, let's pretend, let's write it in green as well. Let's pretend they told you that f of x equals x squared plus 3x minus 4. If you are changing the sign of x to get h of x is going to be equal to negative x squared plus 3 times negative x minus 4. So it would still be a smiley face. Now this is minus 3x, this is minus 4. Okay, so what would happen here is that if you had the first parabola, it would look something like that. That would be f. Then when you reflected it over the y-axis, it would then end up looking something like this. So your h of x would be like that. And that would be h. Does that make sense to you? That's a reflection over the y-axis. Oh, you don't, as far as the hyperbola is concerned, in the hyperbola, they don't generally get you to reflect over, but it would be the same idea with this one, where maybe you can just explain to me exactly what you want me to do, Gugu. All right. Do you want me to show you one with the orange one as well, guys? What I meant by that, about the change of f of x. So y changing sign. Do you want me to show you what I mean by that? Yes, Gugu, go for it.
Hi, ma'am.
Hi, Gugu.
I meant like in a hyperbolic function, whenever like the graph is reflected about the x-axis, how would the denominator be affected?
Oh, okay. All right. So that's what you're asking me. Okay.
Yes.
So, all right. So let's go over here and let's create some space for ourselves. Okay. So let's pretend we have got a hyperbola h of x and it is equal to 2 over x plus 1. And over here, let's say plus 3. All right. And now what we want to do is, you said you want me to reflect it over the x-axis. Compared, right. Okay, so if you reflect it over the x-axis, it means that y must change sign. So let's say my new function is called k of x. Okay, so in other words, k of x equals minus h of x, like so. So what you could do here, Gugu, is you're going to put the minus in the front, and then you're going to put the 2 over x plus 1 at the bottom, plus your 3. And now it's almost like you were in grade 8. Remember when you had something like this in grade 8, where you had 2x plus 3y and it was in brackets and there was a minus in front. The negative changed the signs of the terms inside. Now, when you are multiplying the negative by the first term, you're not multiplying the negative one by the numerator and by the denominator. And I think that's what you're asking about. So what I would do here is I would only multiply it by the numerator, because essentially what you've got is negative 1 times 2 over x plus 1. So that would give you negative 2 over x plus 1. So that's exactly what you'd end up with here. So you'd have negative 2 over x plus 1, and negative times a positive would be a negative, and that would be minus 3. Sorry, I'm scratching that out. But that's what would happen. Okay. So in this case, your a value would change sign and your q would change sign as well.
Okay, thank you, ma'am. You started like lagging, so I couldn't hear you properly, but I understand. Thank you.
But you understand what I'm doing here. Okay. All right. Okay. And just in the last couple of minutes, if they want you to shift the graph left or right, they will add or subtract onto x like they are over here. If they want you to move something up or down, it will be a separate integer onto the end. So here they are asking you to shift the graph 2 units left or right. They're asking you to shift it to the left-hand side. Okay, so yes, it would go to the left-hand side. All right, so if you added 2 onto X, it would shift the graph 2 units to the left. If they want you to, so if they do something like this, if they say that h of X equals f of X plus 2, can you see they have added 2 onto Y? All right, so that means, so here we have shifted shift to left. Here we are shifting to up. Okay, so adding onto Y moves something up. Minusing something from Y moves it down. Okay, adding onto X moves it to the left. Subtracting from X moves it to the right-hand side. Okay, so we've just managed to cover those as well. Now, the other things that I wanted you to do just very quickly, these will obviously be sent to you. Hi, sorry, she's not here at the moment. Thank you. Sorry about that, everybody, just somebody knocking at the door. I want you to just take a picture of this. So calculus. So just things to be aware of. Again, it's just common errors that come up. Correct notation for first principles. Use brackets. Be careful of your notation when you're using your rules. So don't write dy over dx if you're not applying your power rule. Apply your laws of exponents correctly. Use the right algebraic manipulation. Know the difference between a function f of x and its derivative f prime x. Sorry. My apologies, I left the prime symbol off. Okay, that looks terrible. Understand the concept of concavity and know that there are 2 ways for finding the point of inflection. So I had mentioned that to you guys last time. You could either use midpoint formula. Gosh, we've run out of time already. Or you can use your second derivative. The other thing that I wanted to give you some little hints on was probability. So read the question carefully to determine what is required. Understand how to apply the rules. Know the difference between adding probabilities or when you are multiplying. And then be careful with FCP. And it's better to use reason and logic rather than learning rules. Okay. The other place where I had also just put together some hints for you was here with trig. Sorry, I've gone over time here, but you can screenshot these as well. So there's the first one. Make sure you know all your formulae. So your reduction formulae, check your calculators in degrees. Use your answer book to plan your exam. So either do your trig first or last. Don't make up new rules. Show all your steps. Make sure that you show what you get when you are reducing. Algebra. Make sure you've learned all your grade 11 and grade 12 trig, and be careful. Do not ignore instructions like without the use of a calculator. And then the last one I wanted you to just take a screenshot of. Learn your reduction formulae and know which formula to use in a given situation. So in which quadrant you are working. Be aware the quadrants when determining the signs of trig ratios. Okay, so just some more little hints and tips. Redraw a 3D diagram into separate triangles. Identify the links between the triangles. Identify 3 given sides or angles for substitution. use your formula sheet. Another thing that when we say use your formula sheet, so often when we mark trials exams, you've been given the compound angle formulae, you've been given the double angle formulae, and then they are copied correctly because somebody just didn't bother to look at the formula sheet correctly. So just be careful about that. And then the rest of it is all pretty much the same. Okay. So you guys can have a look at that as well. Right, if there are any more questions that you want to ask about some of the hints and the tips that I've given you today and just the common errors, then you can certainly ask me next time at Bootcamp. Yes, you can pull the data sheet off the exam paper, absolutely. And just like in trials, your paper 2 will be done in a book. So you can do your stats and your analytical geometry first, and then choose. If you're better at Euclidean geometry, do the Euclidean geometry first. If you're better at trig, do the trig first. Okay, even in paper 1, you don't have to answer things in order. Okay, but yes, you can certainly separate the formula sheet from the exam paper. Okay, any last questions? Oh, that's lovely, Lebogang. I'm so glad you feel as though you've learned so much. We've got so much more that we can possibly talk about. Okay, Msomi, just very quickly, when they talk about x times f to the -1 of x, I won't Kutwano. Okay, I get Watobe will send them to you. Okay, but I'll just remind them that needs to happen. So here, Msomi, what they're talking about is that they're talking about x times the y of the inverse has to be smaller than 0. So if you are multiplying, so your x coordinates can either be negative or positive, depending whether you're on the left of the y-axis or on the right of the y-axis. So if you want a negative outcome, either this must be negative when that's positive, or that must be positive when that's negative. So either you need to be, if the signs are opposite, you've got to look for you're either going to be in quadrant 2, this would be in quadrant 2, or in quadrant 4. Those are the quadrants that you would be looking at to get your answer. Okay. Does that make sense?